Have you ever stopped to think about the hidden physics behind, well, everything you do? From throwing a frisbee to just lifting a bag of groceries, our world runs on a set of invisible rules. Today, we're going to pull back the curtain and see what they are. Let's dive in.
Okay, so let's kick things off with a little bit of a puzzle. What on earth could a kid tossing a frisbee in the park have in common with a gigantic cargo ship out on the ocean? I mean, one's a toy, the other's an absolute beast. But in the world of physics, they're closer than you think.
The answer? It's all about force and energy. The frisbee flies through the air because of the muscular force from that kid's arm, while that massive ship floats because of the buoyant force of the water pushing up on it. See? They're both playing by the same fundamental rules of the universe.
All right, so let's dig into that first key ingredient, force. It really is the starting point for every single action, every movement that happens anywhere. It all begins here.
So what is a force? It's actually super simple. It's just a push or a pull. That's it. Pushing a door open is a force. Gravity pulling an apple down from a tree, that's a force too. It's just how things in the universe interact.
But here's where it gets really interesting. A force isn't just some abstract idea. It has real, tangible effects on the world. It can get something moving, stop it in its tracks, change its direction, or even change its shape entirely. Let's take a quick look.
First off, a force can get something that's just sitting still to start moving. You know, a frisbee on the ground is just a frisbee on the ground, until you apply a force and send it flying.
A force can also take something that's already moving and completely change its direction. Think about a tennis ball flying over the net. Wham! The racket applies a force and sends it right back the other way. And finally, a force can literally change the shape of an object. When you squeeze some dough or a piece of clay, you're using force to completely alter its physical form. Now, to make things a little easier to wrap our heads around, we can basically split forces into two big groups. You've got your contact forces, like using your muscles or the force of friction. They have to actually touch something. And then you have the forces at a distance, like gravity and magnetism, which can work their magic without touching at all.
Friction is a fantastic example of a contact force, and its whole job is to oppose motion. Look at this skier. On a super smooth, icy surface, there's very little friction, so they can just glide and glide. But on a rough surface, all that friction kicks in and slows them right down. It's a force we are constantly dealing with, every single second.
So, okay, we get force, but what do you need to create a force? You can't just wish an object into moving. You need a source of power. And in the world of physics, we call that power energy.
Energy is simply the ability to do work, or to put it another way, it's the juice you need to apply a force. The food we eat gives our muscles the energy to push and pull. The energy in the wind is what can make a giant turbine spin. It is literally the fuel for all action.
And this energy comes from all sorts of places, which we can split into two main buckets. You've got renewable sources, like the sun and the wind, which are pretty much inexhaustible. And then you have non-renewable sources, like coal and oil, which are finite. Once we use them up, they're gone for good.
And as a species, we've gotten incredibly clever about harnessing that renewable energy. We've got solar panels that drink in sunlight, hydroelectric dams that use the immense power of moving water, and even biomass that converts organic matter into fuel. It's pretty amazing stuff. So we have force, and we have the energy to create it. But we humans, we're innovators, right? We figured out how to use our energy way more efficiently and amplify our force. How did we do it? We invented machines.
Now, when I say machine, don't start picturing some complicated robot. A simple machine is a super basic device that just makes work easier. It's a clever tool that acts like a force multiplier, giving us a huge physical advantage.
The absolute classic simple machine is the lever. And it turns out there are three different types or classes. The only thing that changes between them is the arrangement of three key parts: the fulcrum, which is the pivot point, the load, which is what you're trying to move, and the effort, which is the force you apply.
Let's look at a real-world example to make this stick: a wheelbarrow. It's a class 2 lever because the load, all that heavy dirt or whatever, is in the middle. This specific design gives you a massive mechanical advantage, letting you lift a heavy load with way less effort.
But levers are just one type of simple machine. The wheel and axle is another totally brilliant invention. For centuries, it's been used to lift heavy buckets of water from wells, a job that would be incredibly difficult with just your bare hands.
In total, there are 6 of these classic simple machines. But here's the key idea to remember. They all work on the exact same principle. They allow you to trade applying a small amount of force over a greater distance for a massive amount of force over a short distance. They're all just brilliant hacks that let us bend the rules of force in our favor.
So let's wrap it all up. Force is a push or a pull. Energy is the power you need to create that force, and simple machines are the clever tools that help us use that force way more effectively.
And that's what's so cool about all this. This isn't just some boring science lesson. From the moment you push yourself out of bed in the morning to pulling open a door, you are constantly using these principles, probably without even thinking about it.
These are the fundamental principles that have allowed us to build everything, from skyscrapers to spacecraft. They aren't just rules to learn, they are the tools we use to create. The physical world is like a giant set of building blocks. Now that you can see them more clearly, what will you build?